Okay, so good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is Hampeo Kliman. And to those of you that are new to this channel, just make sure that you do subscribe, hit the like button, and of course, don't forget to share to others. So today we will be doing the chain rule in calculus, and I hope this video will be of help to you. And please, if you find this video helpful, don't forget to comment and also don't forget to subscribe. So now I'm going to make the chain rule as easy as I can so that you'll be able to answer almost every video or almost every question rather that you'll be encountering that is concerning this topic. Okay, so I do have some good practice examples here, and with me we'll be going through them together. Okay, so let's get started without wasting much time. We have been given y, that is for a. I'm going to be very fast, but of course you'll be understanding my concepts. We have y equal to x to the power 2, then x to the power 3 plus x, everything to the power 4. The secret to the chain rule is simply understanding the person that is standing outside the car and the person who is seated inside the car. Okay, so let me do this. We have this person here. Okay, then of course we do have this car here. I'm not good at drawing anyway, but this looks like a car. Okay, so now we have this person here. I name him A and I name the vehicle B. Then we have another person who is seated in the car. Okay, now one thing that you must be able to understand is this. When you're dealing with the chain rule, usually the chain rule usually works with the product rule of calculus, because we understand that this individual person outside the vehicle and the person seated inside the vehicle are two different people, but in the same environment. So this guy is multiplying this vehicle, okay? But then this guy is not multiplying the guy outside. It's the vehicle which is multiplying the guy who is outside. You understand? So for you to use the chain rule, or for you to use the chain rule, rather, you are supposed to deal with the guy outside, okay? So you are supposed to find dy over the x of the guy outside. Then you find dy dx of the vehicle, just the vehicle. Then you find dy dx of the person inside the vehicle. Well, how does that apply? So this is what we're going to do, because we understand that this is the product rule we are using. So we're going to introduce our dy over dx. dy over dx is equal to, so I will start first of all by differentiating whatever is outside, because we're using the product rule first, because we know that we're multiplying this, and then we're multiplying this vehicle, which are the brackets, and everything inside the brackets. Okay, so what are we going to do? We will first of all deal with this part. So what is dy dx of x to the power 2? And of course it's just 2x. Since it's the product rule, we are going to maintain this guy. So it will be x to the power 3 plus x, everything to the power 4. Okay, then we say plus. Now, this time around, we are going to maintain this guy. Then we deal with this guy. But remember, I said that we first of all find dy dx of the vehicle. In this case, which one is the vehicle? The brackets. So we're going to find dy dx of the brackets. Remember, the brackets are carrying the power 4. So in this case, we are going to say that the 4 will come to the front. So of course we're going to have 4 here, open bracket, then x to the power 3 plus x, then everything to the power 3 because we're subtracting by 1. Then from there, we now deal with the guy inside. We find dy dx of the guy inside. So what is dy dx of the guy inside? It is just 3x to the power 2 plus 1. Okay, so this is just how simple the general is. So in this case, our final answer will be 2x, then x to the power 3 plus x all over to the power 4 plus, this is going to be 4x to the power 2, then x to the power 3 plus x, everything to the power 3, then 3x to the power 2 plus 1. Okay, so this is our final answer. So you better leave it here. If you want, you can expand it, but you don't have time in the exam, so you better leave it here. Okay, so which one is the second question? Of course, we've done the first question. We get to B. So B, we are going to use the same concept. They're saying y is equal to x to the power 2, then e to the power negative 3. The same concept applies here. So dy over dx. But then the question that many people ask is, how do you know when to use the product rule and the chain rule? Okay, I'm going to show you here. So we are multiplying this algebraic expression and this trigonometric expression, right? So whenever you are multiplying algebra with trig or any other thing, or algebra by algebra, as long as you are able to say demarcation sum, you know that's the product rule. But as long as you know that there is some other equivalents that are attached to that particular expression that you are dealing with, then you know that the chain rule must be involved. So in this case, we will start with x. So what is x to the power 2 of dy of dx? That is just simply 2x. Of course, then we maintain this part. So maintain our part there. We'll maintain our part like that. So I'm going to maintain my part. Then I'll say plus. Now here, better be careful because this is x to the power 2 multiplied by, then I say dy over the x of, that is e to the power 3x. Okay, like that. Then I say multiplied by dy dx. This time around, who is inside the car? Is this guy here. This guy is inside the car. So that's the guy inside the car this time around. From there, we say dy over dx is equal to 2x e to the power 3 plus, this is x to the power 2. What is dy dx of e to the power 3? It is just e to the power 3 x multiplied by, this is just negative 3 because dy dx of negative 3 is that. Therefore, we say dy over dx is equal to 2x e to the power negative 3. Okay, this is x. And of course, we say minus 3 x to the power 2 e to the power negative 3. We are done. All right, so this is just how you solve this particular question. This is how you solve this particular question. It's very simple, very, very much simple. We get to C. For C, the question is very simple as well. But for C, I put it there deliberately because I want to show you how to solve questions like this one. Okay, so you have the square root of, okay, so this is the square root of, I'll show you the simplest method. This is x to the power 3. So whenever you have a question that has a square root somewhere, It doesn't matter what they put there. Please just know that you are using implicit differentiation. How? You're going to introduce the natural log. So the natural log is going to help us here. How do I know? Because I have a radical here, okay? I have a radical there. How is it gonna help me? Let's try to do this. So if I introduce ln to y, okay, then I also introduce ln to everything here. Then I know everything is gonna be simple. Why? Because I know that this is just the same as ln y equal to ln of, is just the same as root of 1 plus x to the power 3 minus, okay, so these are rows of trigonometry. So from here, I know that dy dx of ln y is just 1 over y dy dx. This is what you learned in implicit differentiation. And that implicit differentiation. So equal to, then I know that this can also be written as ln of 1 plus, what's this? Okay, let's just do this 1 plus x to the power 3, everything to the power 1 over 2, this is the square root, minus, okay, so this just, let's just put it as ln x to the power 3, just like that. From here, we have 1 minus y dy over dx equal to, okay, so we have this 1 over 2 can come to the front like that. We're going to have 1 over 2. Then what is dy dx of ln of everything? dy dx of ln of an algebraic expression is simply the dy dx of that algebraic expression over the original equation. So what is dy dx of this? It is just 3x to the power 2 over the original equation, which is 1 plus x to the power 3. Like that. Minus 3x to the power 2 over x to the power 3. Now when you reach here, you're not yet finished. Okay, so I want to remain with dy dx. So for you to remain with dy dx here, you're going to say y over 1, then multiplied by y over 1. So that this guy and this guy can go, then you're going to remain with dy over dx, going to make dy over dx equal to, this is just the same as 1 minus 2. Okay, let me just put 3x to the power 2 all over by 1 plus x to the power 3, like that. Then I say minus, okay, so this is gonna be 3x to the power 2 over x to the power 3. Then I put my y here. So to end everything up, this is just the same as dy over dx equal to, this is gonna be 3x to the power 2 over 2, 1 plus x to the power 3. Then of course, this is gonna be 3x to the power 2 over x to the power 3. Then I get my original y equation, which is here. And I'm going to put it where there is y. So this is just the same as square root of 1 plus x to the power 3 over x to the power 2. Okay, so this is how you differentiate this particular question. It's very simple. Okay, so I want you to try this one. You can try this one. It's just the same concept anyway. And which other one? Okay, you can also try this one using the chain rule. Thank you so much.